This is the third part of the chapter, activation and inactivation of biologically active molecules. So, in this video, in this part, I'll talk about inactivation or activation of insulin hormone. Okay, if I want to say more precisely, I'll talk about antibody-mediated inactivation of insulin hormone. Okay, so as I'm talking about insulin, so we all know, right, why insulin is important. So, if there is something wrong with the insulin, if our body don't produce enough insulin, or if our body can't utilize the insulin, we will get diabetes. Okay, so as we're talking about the insulin hormone, so we should have some good idea about the diabetes. So let's see whether we can learn what is diabetes. So what is diabetes? Okay, uh, diabetes mellitus. It is a general term for a heterogeneous group of diseases that have as a common denominator abnormalities in carbohydrate metabolism associated with a deficiency in the production or utilization of insulin. In case, if we get diabetes, our carbohydrate metabolism is abnormal. Okay, so there is some abnormalities. If our body cannot produce enough insulin, or if our body cannot utilize the insulin, there will be abnormalities in carbohydrate metabolism. Okay, and diabetes can cause some long-term effects, such as long-term damage, dysfunction, and failure of various organs. Okay, so uh, let's try to get some more idea about the insulin. So we actually all know. I'm just just for our recap. So insulin is an endocrine hormone which is produced by the beta cells in the islets of Langerhans in the pancreas. Okay, and many of our body cells, they have receptor for the insulin. So insulin can bind with this cell, and they can stimulate transport and utilization of glucose, which is in the blood. Okay, for the conversion, and this glucose then are converted into energy, or they are stored as glycogen in the liver. Okay, or glycosides in fat cells. Okay, and in case of diabetes, diabetes can be resulted from impaired production or decreased utilization of insulin. Okay, which will result in increase in blood glucose. Okay, and thus, because this increase in blood glucose, some abnormalities of metabolism will, I mean, occur, right? Okay, and decreased insulin utilization, it can be resulted in, because of several different reasons. Okay, so like for example, impaired insulin secretion, loss of receptors or receptor response, or presence of blocking antibodies to insulin or to the insulin receptor. Okay, all these reasons can cause decreased insulin utilization. Okay. Okay, so as we're talking about the insulin, and diabetes, it's better to get clear idea. Actually, what happens? Okay, uh, I mean, how insulin help us to absorb the glucose. Okay, so the cells, who responds to insulin, they have insulin receptor. Okay, so insulin receptor has four subunit. Two subunit is may two subunit are alpha subunits and two beta subunits. Okay, so the alpha subunit, they can bind with insulin. Okay, so when the insulin is not bind with this alpha subunit, the insulin receptor is in it's is in inactive form. So first the insulin, they bind with the alpha subunit. Okay, and they get activated. Okay, so when the insulin bind with the alpha subunit, this portion, the cytoplasmic portion of the receptor, they get activated. Okay, because of phosphorylation. Okay, I have to tell you one thing. You know, many of this receptor is also actually a protein. So in our body, many proteins, they get activated through phosphorylation. When they're in inactive form, they are dephosphorylated, and because of phosphorylation they get activated. Okay, so this insulin receptor in inactive form, no phosphorus, that is they are in a dephosphorylated form. After the insulin binds with the beta subunit, they get activated through phosphorylation. So once the receptors are activated, they can activate some substrate. Okay, there are some substrate in the cytoplasm which are called insulin response substrate, IRS. Okay, so the IRS get activated and they instigate some cellular responses, okay, which eventually tell the cell that you have to now get glucose, you have to absorb glucose from the blood cell. Okay, actually the cell has glucose transporter. I mean, when the insulin receptor surface they get activated, eventually a series of cascade occurs, and eventually the glucose transporter they get activated. Okay, and once the glucose transporters are activated, they can absorb the glucose from the blood. Okay, so there are two types of diabetes. We all know type 1 and type 2. Type 1 is insulin dependent and type 2 insulin independent. Okay, and about 20% of patients they have insulin dependent, that is type 1 diabetes. Okay, so that is, these patients, the insulin in these patients, the insulin receptors or responsiveness cells are normal, but insulin availability is low. Okay, actually in for these patients, the amount of insulin in their body is low. And in case of insulin independent or type 2 diabetes, the remaining 80%, 20% patient, they usually have the type 1 insulin dependent diabetes. But the rest 80%, they have insulin independent, that is type 2 diabetes. Okay, in this case, insulin availability is normal. Actually, there is enough insulin, but the number of receptors is low. Insulin, the amount of insulin is normal, but our cell they cannot utilize the insulin. That means insulin utilization is low. Okay, so there are many reasons which can cause the diabetes, but diabetes can be caused because of immunological reason too. Okay, and both type 1 and type 2 diabetes, they may have immunological origins. That means antibody, because of antibody. There are several antibodies which can cause type 1 and type 2 diabetes. Okay, so uh, uh, let's try to learn about the antibodies which can cause the diabetes. Okay, so these are some antibodies, different antibodies who are associated with diabetes. For example, one, antibody to islet cell. Okay, antibody against the islet cell. Uh, okay, they can cause type 1 diabetes. Basically, in this case, most of the antibodies they are induced against a enzyme. This enzyme, glutamic acid decarboxylase, which enzyme is present in the islet cell. Okay, so antibody can be induced against the glutamic acid decarboxylase. Okay, and eventually they can react with the islet cell. Right? Okay, and inactivate them. So it will cause type 1 diabetes. Some antibodies to insulin, it will also cause type 1 diabetes. Antibody to insulin receptor will cause type 2 diabetes. Loss of insulin receptor, that is insulin resistance. Okay, this is called insulin resistance, type 2 diabetes. Failure of cells to respond to insulin receptor, it will also cause type 2 diabetes. Okay, so these were just some text. So I think from this text it's difficult to get the clear idea. So let's see this photo. Okay, this is a graphical representation what is said here. Okay, so say these are the islets of Langerhans of pancreas. Okay, they produce the insulin and then secrete it. Then this insulin they bind with the receptor of the cell. Okay, so once they bind with the receptor of cell, a series of events get activated or happens in the cell, which eventually cause the glucose metabolism. Okay, so I mean antibody, and there are different antibody who react in different area and which can cause diabetes. For example, some antibodies, okay, they can react with the islet cell itself and cause destruction of those cells. That is, they can inactivate the islet cells. So in this case, the islet cells, they are getting destroyed. Okay, so they cannot. Enough insulin cannot be produced, which will cause type 1 diabetes. Okay, and some antibodies, they can react with the insulin. Okay, so as this reaction, as these antibodies, they react with the insulin. That means this antibody bind with the insulin. So thus the insulin, they become unavailable. I mean the insulin is there, but as this insulin, they are bound with the antibody, so they are no longer functional. That means they are already bound, so they cannot bind with the receptor of the cell. Okay, so this will also cause type 1 diabetes. Some antibodies, they can bind with the receptor and block them. So as this antibody, they bind with the receptor, the insulin cannot bind with them. This will cause type 2 diabetics. And some antibody, they can bind with the receptor and cause destruction of this receptor. Okay, so again this will cause type 2 diabetes. Okay, and there are some antibodies, okay, which can there are some antibodies, there and their effects can cause the failure of cells to respond to activated receptors. Okay, even insulin will bind with the receptor, and they will, they will develop some signals, but they will cause some response, but the cells will not be able to act upon those response. Okay, again this will cause diabetes, type 2 diabetes. Okay, so now I'll talk in more details about this different antibodies. Okay, first, antibodies to insulin. Okay, so this kind of antibodies are often found in patients who are administered exogenous insulin. Insulin has been given to them. Okay, by injection. Okay, however, most such patients show no increase or decrease in insulin requirements. Okay, and this kind of problem can be alleviated. So, for example, if we produce the human insulin by gene cloning techniques, a less immunogenic molecule, okay, less immunogenic reaction occurs. But actually, however, I mean, even this way, it does not completely eliminate the possibility of antibody formation. Okay, because even the antibody which is, even the insulin which is produced by gene cloning, our body can still recognize them as foreign. Okay, and if our body recognize them as foreign, our body will produce antibody against them. Okay, so now antibodies to islet cells. Okay, sometimes autoantibodies can be produced against the islet cell. Okay, so if autoantibodies are produced against the islet cell, they will react with the islet cell and inactivate them. Okay, actually, in many juvenile diabetes cases. Okay, so like let's say in many juvenile diabetics case, they are they starts because of the autoantibodies. Okay, and 80% of patients with recent onset autoimmune destruction of beta cells have antibodies to the cytoplasmic enzyme glutamic acid decarboxylase. Okay, so these antibodies, autoantibodies, they will destroy the islet cells, but these antibodies can be generated against different part of the islet cell. Islet cell is a cell, so like they have many different proteins there. Okay, they are, the islet cells, they are made of many different kind of proteins. So autoantibodies can be induced against those different part of the islet cells. Like for example, what here is said that this enzyme, there is an enzyme, okay, glutamic acid decarboxylase. this enzyme is expressed by the islet cells. That means you can find this enzyme in the islet cells, and autoantibody can be induced against this glutamic acid decarboxylase, and these autoantibodies will react with them and eventually cause the destruction of the islet cells. And in case, like in the diabetics case where the islet cells are destroyed, 80% of those cases occurs because of the production of autoantibody against this glutamic acid decarboxylase enzyme. Okay, and in this case, the initial destruction of beta cells is mediated by T cell. Okay, not by antibody directed mechanism. Okay, and in humans, acute onset juvenile diabetes begins with lymphocyte infiltration of islets, and the actual immune-mediated destruction of the beta cells is caused by cell-mediated immunity. Okay, that means initially the destruction of the beta cells is mediated by T cell, but the acute case actually it is caused by lymphocyte infiltration. Okay, and and by cell mediated immunity. Okay, so that's all for this part. In the next part, I'll talk about another example. Okay, another example of antibody mediated inactivation and activation, and I'll talk about the thyroid hormone. Okay, see you in the next video. Thank you.